Hello everyone, welcome to the channel Statistica Hub. So in this lecture we are going to discuss about standard Z scores. Standard Z scores. Okay. So in the previous lecture we have seen that how the standard deviation can be used to measure how variable a set of values are. Okay, now and we have used to pick out the most reliable player for the basketball team in the example of the basketball team. Okay, now imagine a situation in which you have uh, two basketball players two basketball players. Okay, and these two basketball players are of different ability different ability. Okay, the first player gets the ball into the net on an average of 20, let's say 70% of the time. 70% of time, and he has a standard deviation of 20%. Okay, and the second player has an average of 40%, that is mean, and of time and standard deviation of 10%. Okay, so we have a situation where we have two basketball players of different ability. Okay, the first player has average of 75%, 70% of the time, that is the mean of 70% of the time, standard deviation of 20%. Okay, and the second player has the mean of 40% of the time, and the standard deviation here for the second player is 10%. Okay, now in a particular practice session, player 1 gets the ball into the basket. Okay, in a particular practice session, we are talking about a particular session. In that particular session, the first player gets the first player gets the ball into the net 75% of the time, and the second player gets the ball into the basket 55% of the time. Okay, now the question arises is that which player does best against their personal track record. Okay, so these are their personal track records, that is mean and standard deviation, the second player's mean and standard deviation, and in a particular session, in a particular match, they have scored 75% of the time and 55% of the time. Okay, now the question is, what is the question? The question is that which player does better regarding their personal track record. Okay, so these are the corresponding information about the players that we have, and we will use this to compare about between these two players. Okay, now let's see it. What if we need a baseline for comparison? Okay, so this is the case when we have two players and we need a baseline to compare between these two players. Okay, so in this case only we have these two players. Okay, and for comparing the scores of these two players, we need a particular baseline, so we can easily compare the scores of these two players, because we can see that they have the standard deviation for both the players are different, the mean for both the players are different, and the particular sessions performance for both the players, they are also different. So the question is that how can we compare the performance of these two players? Okay, so first thing here is, it is saying that that's easy. Player 1 does best because it has a mean. Player 1 has mean of mu of 70 and standard deviation of 20. Okay, 20% and 20% and 70%, and the player second has the mean of 40% and the standard deviation of 10%. Okay, and what are their particular performance in a particular match? The first player has scored 75% of the time, and the second player has scored 55% of the time. Okay, now it is asked that which player does best against their personal track record. So it is saying that that's easy. Player 1 does best. player 1 scores 75% of the time and player 2 scores 55% of the time. Okay. Okay, so it is saying that player one scores better. Okay, now just looking at the percentages don't give us the full picture actually. Okay, so 75%, that sounds like a very high percentage, but we are not taking into account the mean and standard deviation in this case. If we are looking only at the percentages, then we are not taking into account the mean and standard deviation of each player. Each player here has scored more than their personal mean. You can see that they have scored 75%, which is greater than 70, that is the mean for the first player, and second player has scored 55%, that is a greater than his mean, that is 40%. Okay, now but which has fared better against their personal record? Okay, now let's see them by a graph. These are the corresponding graphs for the player. For the first player, we have mu, that is mean, at 70, and the standard deviation as 20. Okay, and this is his personal record, personal particular performance, that is of 75. Okay, for the second player, it has mu of 40, the standard deviation of 10, and a particular value for the performance is 55. Okay, so they have performed like great, they both values have are greater than the mean. Each player has scored more than their personal average. Here you can see that it is 70, it is 75, it is 40, it is 55, so they have scored more than their personal average. Okay, now see it here, the two players have different means and standard deviation, so how can we compare their personal performance? How can we do that? So does this sort of situation sound impossible, or is there any way to compute this kind of situation? Okay, so here comes the concept of standard score, or you can say Z score. Z score. Okay, now what is this Z score and what is this standard score? How can we use it? How does it imply, and how it imply the results of the data, and how does it help in comparing this particular sets of data set? Now let's see it. Okay. Okay, so use standard scores to compare values across data sets. Okay, so standard scores gives us a way of comparing values across across different sets of data. So data, okay, where the mean and standard deviation differ. Mean and standard deviation differ. Okay, now they are actually a way of comparing related data values in different circumstances. Okay, now you find the standard score. How to measure the standard score is, you find the standard score by using a particular value of mean and standard deviation of the entire data set. We are going to use the value of standard deviation and mean of the entire data set, and the standard score is normally denoted by Z. Okay, this is the notation for the standard score. And to find the standard score for a particular value X, okay, for value X, the computation is Z is equals to X minus mu by sigma. Okay, it is written here that Z is equals to X minus mu by sigma. Okay, these are the mean and standard deviation. Here, this is mu, this mu and sigma are the standard deviation and mean of the set of data that contains the X. Okay, now we are computing it. Let's calculate the standard score for each player and see what those scores tell us. Okay, so let's just compute it for the first player. For the first player, we have X, the value of X, that is the score that he got for a particular match, that is 75. So 75, the mean for the first player is 70 and the standard deviation is 20, right? So let's compute it. This is 5 by 20. So we got this 1 by 4, that is equals to 0.25. Okay. Now what is the standard score for second player? For second player, we have X, that is equals to 55 for a particular match. So the standard score for the second player is Z is equals to 55 minus, what is the mean? 40 divided by 10. that is equals to 15 divided by 10, which is equals to 1.5. Okay. So using the mean and standard deviation to standardize the score. Here what we are doing is we are standardizing the score. Standardizing the score. Okay. The player 1 gets 0.25 and player 2 gets 1.5. Okay. Now you can see that compared with the, if we compare the scores of these two players, what does this actually mean? You can see that this has a higher standard score and this has a lower standard score. Okay. Now let's see it. We have calculated the scores, the standard scores of these two players. That gives us Z 0.25 for the first player and Z of 1.5 for the second player. Okay. Now let's see the interpretation of these two scores. We have these two scores of the player 1 and player second. Okay. So let's see the interpretation of this. Standard scores give us, what does the standard score give? The standard scores give us a way of comparing values across different sets of data. Okay, so when the sets of data have different means and standard deviations, okay, they are a way of comparing values for different sets of data of different mean and different standard deviation. Okay, now, so what does this mean for our basketball player first and second? For our basketball player first and second, let's see that. Okay, now look at here that each player's shooting success rate, has a different mean. One has a mean of 70 and other has a mean of 40. They have different means. Okay, which makes it difficult to compare how the values are performing relative to their own track. Okay, now we can see that in particular practice, one player got the ball in the net more times. That is, the first one gets 75% and the second one gets 55% of the times. Okay, so this player has got more times into the basket than the second player. This is my first and this is my second player. Okay, we also notice that both players are scoring at a higher rate than their average. Okay, because its average is 70, it is scoring at 75. Its average is 40 and it is scoring at 55. So they both are scoring at a rate higher than their average. Okay, so the difficulty lies in comparing performances relative to the personal track record, is that the values are different to each other. Okay, the standard scores make such comparisons possible by transforming each set of data into a more generic distribution. We will see that what does this generic distribution mean. So we can find the standard scores of the each player at the practice and see the results of this. Okay, so this is player 1 which has sorry, ignore this. So this is player 1 which has standard deviation of 20 and mean of 70, and he has scored above is 75 in a particular session. Okay, and for the player second, mu is 40, sigma is 10 and it is 55. So it's difficult to compare these two sets of data directly, but we can compare them with Z scores. So for the first player we got Z scores of 0.25 and for the second player we got the Z score of 1.5. Okay, so this is my Z, this is my Z1 and this is my Z2, and this is the result of this the comparison of these two sets of data. These are the standard scores for the two players. Okay, this is super generic distribution Z. Generic distribution Z. Okay, now in this we can see that this Z1 is less than Z2. Okay, so what does this tell about what does this tell us about the players? Okay, so the standard scores for player 1 is 0.25 while the standard score for player 2 is 1.5. So when we standardize the scores, the score of player 2 is higher, right? The Z1 is less than Z2. This means that even though player 1 is generally a better shooter, because 75% he has scored 75% of the time, he is generally a better shooter, but pulls it, but balls into the net. I'm sorry. This means that even though player 1 is generally a better shooter and put balls into a net at a higher rate. Okay, the player 1 put the ball into the higher rate, but player 2 has performed better relative to his own track record, because it has standard score of 1.5. He has performed better, player 2 have performed better. Okay, now let's see the computation of this standard score and what does the generalized generic data distribution means. Okay, so the standard scores work by transforming the data, transforming sets of data into a new theoretical distribution which has mean of 0 and standard deviation of 1. It's a generic distribution. What? This is a generic distribution which has mean of 0 and the standard deviation of 1. Okay. Now, this generic distribution is used to compare the data sets. Standard scores effectively transform your data so that it fits this model while making sure it keeps the same basic shape. Okay, this is for to standardize the data set. Okay, so if we have this type of data, okay, here this is the mean, this is mean, and this is my standard deviation. Okay, this is sigma. Okay, so in this generic distribution, when we are going to compare the two sets of data, we are going to compare them by the use of generic distribution. In this case, the mu is 0 and the standard deviation is 1. Okay, see it here that we have, this is the spread of the data, this is the mean, and this is the deviation that we have here in the generic distribution. We are talking about the generic distribution. In that we have mean of 0 and the standard deviation of 1. Okay, so standard scores can take any value and they indicate positions relative to the mean. Okay, so in the previous case we have this as z1 and this as the z2. Okay, these are the standard scores at that time. So positive z scores, whenever we have a positive z scores, it means that your value is above the mean, above the mean. Okay, and the negative z score, it means that the value is below the mean, below the mean. Okay, below the mean. And if your z score is 0, then the value is the mean itself. Okay, so the size of the number shows how far away the value is from the mean. Okay, what does this size shows? This size shows that how far away the value is from the mean. Okay, now let's see standard deviations from the mean. Okay, now what does this say? Okay, let me raise it. Okay, let's cross it. So now we'll see standard deviation from the mean. Okay, sometimes statisticians express the relative position of a particular value in terms of standard deviation from the mean. Okay, so when we have seen that using z scores transform your data into a generic distribution which has mean of 0 and standard deviation of 1. Okay, so if a value is within one standard deviation of the mean, what does this tell us? That when I say that my value is within one standard deviation, it depicts us that the standard score of the value is between -1 and 1. Similarly, when we say that my value is within two standard deviation, it means that the standard score of the value is between -2 and 2. Okay, so look at it here. We have this graph and you can see, I'm sorry, let me just erase it. Okay, so in this we have the z scores of like -1 to 1. My data, when we say that the standard deviation of is within one standard deviation, that a value is within one standard deviation, it means that the standard score of the value is between -1 and 1. Okay, so you can see that the standard value is between -1 and 1. So this is my -1 and 1, this is mu and this is 0, so it is between this region. Okay, so if a value is within one standard deviation of the mean, it's within this area here, the central part of the data. Okay, so and when a value is within two standard deviation, at this time this is mu and this is 2, this is -2, then the value is between this part of the region, this part of the area. Okay, so the value is between -2 and 2. Okay, now the question here is that, okay, so before the question, it is written that standard score gives us number of standard deviations from the mean. Okay, it does give us the number of standard deviation from the mean because we have this standard score. This is my mean and it is the standard deviation, that is z. Okay, so it is 0 and this is the particular value, let's say 1.5. So it is saying that we have the score of 1.5, which gives us the number of standard deviations from the mean. It is 1.5. Okay, the number of standard deviation, that is 1.5, is the number, that is number of standard deviation from the mean, because the mean is 0 here. Okay, in the standard case we have the mean as 0. Okay, okay, so okay, let's come back. Okay, so the question here is, do standard scores have anything to do with detecting outliers? Outliers. Okay, so do standard scores have anything to do with outliers? Anything, like, do they know that by telling you the standard scores, by giving you the standard score, do you know that whether the data contain outlier or not? Okay, so determining outliers can be subjective, but sometimes outliers are defined as being more than 3 standard deviation. Okay, more than 3 standard deviation. If we have a standard deviation, we have a z score that is of more than, that lies beyond 3 score, beyond 3, that is more than 3 standard deviation, then my data contains outlier. Okay, but statisticians have different opinions about this thought. Okay, so this is one standard deviation, my data can lie between within one standard deviation, two standard deviation, three standard deviation only. But this data can't be lie between four standard deviation, because in that case my data will contain outliers, and this is much high standard deviation, which this is much high z score and phenomena. Okay, so let's see the summary of this data set. Okay, so the variance and standard deviation measure how values are dispersed by looking at how far values are from the mean, right? Okay, what is the formula for the variance? The formula for the variance is sigma x minus mu whole square divided by n. An alternate form is this, that sigma x square divided by n minus mu square. Okay, the standard deviation, this is denoted by sigma square, this is also denoted by sigma square, as these both are the variances. The standard deviation is equal to the square root of the variance, and the variance is the standard deviation squared. So my standard deviation is root of variance. Okay, and what are the standard scores? Standard scores, or you can say the z scores, are a way of comparing values across different sets of data where the means and standard deviations are different. Okay, to find the standard score of a value x, we use the formula z is equals to x minus mu by sigma. Okay, and we generalize a distribution, a generic distribution, and in the generic distribution we have mean of 0 and the standard deviation of 1. Okay, so till now what we have done in the variability and spread, that is, first topic is range, and how can we calculate range? That is upper bound minus lower bound. Lower bound. Okay, Okay, so and the second thing is interquartile range. Interquartile range, how can we measure it? Interquartile range is upper quartile minus lower quartile, right? And what is the formula for the standard deviation? That is sigma, which is root of sigma x minus mu's whole square divided by n. And the second formula is root of sigma x square divided by n minus mu's whole square. Okay. And what is the formula for the standard score? Standard score, that is z is equals to x minus mu by sigma. Okay, and we have done like variances. The variance formulas is this only, just take the square of this. Okay, and we have done deciles and percentiles. So these are the concepts that we have done in the variability and spread. Okay, these are the complete concept of the variability and spread. Let's meet in the another lecture. Thank you.